Hey guys, so I'm Abhishek and I'm going to go walk you through a machine learning model that I made. It's an end-to-end model that I deployed on Heroku and let's go through it. So basically, is there everything is there on my GitHub? So don't have to worry about anything. So yeah. I'm just getting used to OBS Studio again and again. So this is my GitHub. So basically, I'm going to just show you a demo first, and then we'll go through the technicalities of it. So this is my FIFA 19 recommendation and starting bid prediction app. So basically, suppose in a team, like, Messi leaves the team and you want to find a player that you want to replace him with. So this would recommend a list of players that would be suitable for that particular team. And for that particular set of players, it would also give a starting bid prediction so that you get the optimal amount for him to get off the market. So I'll just give you a little demo. So all the instructions are given here, uh, and here are some of the what are the things that what is the algorithm running behind the recommendation part and the starting bid prediction. XGBoost is used for the starting bid prediction, and KNN is used for the recommendation. Anyway, so let's just go. So I'm gonna go with Arsenal. I support Arsenal. I know it's a terrible time to support them, but then what you got to do, man? You got to do what you have to do. And I'm gonna go with center forward. Okay, so this is how I divided the positioning as the people who are in the center. They have a center forward, center midfielder, or center defender. Otherwise, it is side attacker, side forward, side midfielder, and side defenders. The right back and left back as LB and side these things. Okay, so I'm going to choose center forward. So I just copy this and I put it here. And then number of players. So I'm just going to keep five for now. Five players of so upper age limit. So like I want somebody like kind of matured and like good enough striker. So I'm gonna keep it 25. Like he who's in his prime and he's gonna get even better. Okay, that's not the whole point. But anyway, so like let's just see if it works. Okay, so this is the recommendation that it has given me. Here it's all in pounds. So this is 64 million pounds. For Danny Ings, it is 48 pounds, 48 million pounds. Mitrovic, Castello, M. Gomez, Mario Gomez. So these are the players that has been recommended, and these are the starting bid prediction for each player. So this is how my model works. And you can see the other things if you want to go to my LinkedIn. I just open this, and you can come to my LinkedIn page, and then you can see the contact. I know the UI is not the greatest, but I have just started into this whole thing. And then the whole part, you go back to the front page again. So that's all about the app. So I'll just go through the GitHub repo also. So the basically how I ended up with all this is basically I made three parts, divided the project into three parts. So the first part is EDA and analysis. So EDA and analysis, second part is the player recommendation part, and the third part is the bid prediction part. So the data set I got from Kaggle, it's already there, FIFA 19. So there's already a video game on with the football players, and this data consists of basically the attributes of each different players, ranging from the attacker position to the defender, and the goalkeepers have like a different attribute. Okay, like they have a different set of attributes. So the thing is that there were a lot of columns that I had to take out, a lot of data engineering I had to do, so that the data was good enough for any kind of prediction work or recommendation work. But anyway, this so far we are not gone there. So for right now, it's just EDN analysis. So I'll just go through this notebook a bit. So here there are some Indian players in FIFA too, and I just wanted to go through them. And you can see Sunil Chetri, Jingan. Jingan is the Punjabi. He was playing for Kerala Blasters. Uh, so yeah, so these are some of the players. Checking you're gonna check the height of players. The maximum count is 183. That's around like 6 foot, I guess. Yeah, 6 foot. And yeah, so that's the number of like the highest number of players. I mean, yeah. The weight, the maximum number of players is the weight of the players is like 75 kgs. So then you can see like there's other various these things. See now, like I have done on right-footed, left-footed, majority are right-footed. Then you can see the weak foot, like how many 3 stars are there. 3 star is the highest count. And then you can see that the most number of players are midfielders in the FIFA data set. So this FIFA data set was there on Kaggle, but there are some unique attributes that I had to scrape from other websites as well, and then I added them to the data. This thing. It was all in Excel sheet. Everything was done in Excel and Python, Jupyter Notebook. So after a long try, yeah. So this is another one. Based on work rate, preferred foot, you can see again what is the work rate of different categories. Medium high is the greatest. The medium is the highest work rate. So you can see the histogram, the distribution of age distribution of players. Maximum of them are lying in the 25 is the mean, or the median. 25 is the median age, and you can see the histogram here. So that's like the highest is 40, lowest is 15. You can see 20. Everyone's young and everything. So then you can see the peak, like the distribution of the ratings of FIFA players. You can see the highest is 70 rated players, and then slowly we come to the 80 and 90s are only Messi and Ronaldo and some other Kevin De Bruyne and players like that. Uh, so then again you can see some more insights. So here you can see the overall and the age relationship. You can see as the age increases, they reach a good overall status, and then after a particular age, they all just start to decline more and more. So that's kind of insightful. And yeah, then there is age. Based now, it's all about the country-wise distribution, like how many are there in each country. Uh, then there is overall one based on clubs. This was totally for showing off because there's no relation. Okay, like this was just to this is a correlation to basically like just to show the dependence. I have not even removed anything, or I have not made any kind of and you can't read this, so there's no point of this. I just wanted to show off, and I found a lot. So behind this notebook there were a lot of things I had to go through. I had to go through various different notebooks. I had to go through a lot of different Kaggle notebooks, GitHub, to find out how this whole thing worked. So I just put it all in one place so that I can come back to it anytime. So here is some data engineering. So there is wage here. It's all in 565K. I replace it with a thousand, this thing, and I convert pounds to million and everything like that. And then we can see, like, the wage distribution in famous clubs. You can see Barcelona is on the, like, there's an outlier in Barcelona because in 2019 Messi was there in Barcelona. So hmm. So then again, relationship. You can see, yeah. So usually football jerseys, everyone wears a jersey from 0 to 20, and then you can see the potential. Like, uh, the red is 100, so 80 is orange. So you can see, like, most of the players are in, like, whoever is like a crucial part of the first team players are all in the orange part, and they are all below 20 years old. International reputation. Yeah, there are like a lot of these things, and then there are some, like some different. So yeah, this is like according to FIFA, best crossing, best finishing is Messi. Best shot power jumping Cristiano Ronaldo. And pace is are Kevin Ninja Turtle, and left-footed players, and yeah. So these were just the insights of. So that was basically some of the insights. Then comes the recommendation model. So in the recommendation model, we can see, like, I've done a lot of data engineering. I have seen missing value columns. Then I drop all of them. I replace. I actually replace. I'm sorry. I replace them with the mean value, the median value. Uh, and then there are like, yeah, so you mean, and there are like a lot of other things as well, like other body type and everything. And I have to, like, engineer the positions of each, data engineer all the different position groups and all that. Then as we keep going. Yeah, so basically there was a lot of different things. You can go through the notebook anytime you want, and if you have any questions, you can comment below and let me know. So yeah, then I do the scaling part, then I do the recommendation. So the KNN, so it has this distance and rank. The closer the distance, the lesser the rank. Uh, So based on that, I get the, I did for a, so here I just test run for Arsenal and Defender 3 and 11, and I got Jimenez, Akanji and Christensen. So I was just like testing it in the Jupyter notebook itself. And then, I found all these graphs on GitHub, and it was like really cool. So I just, wanted it in my notebook too. So it's basically like the skill chart of each player. Like, see, given us is a red one, so you can see the red chart. It's kind of confusing with the pink. So I just want to see if I'm still recording. Yeah, sure. Okay, so like, yeah, and then so basically after all this, I saved the my data set, like the engineer the final data set I like worked on into pickle format. I also saved the list of the players that I got as a recommendation, and yeah, so that I have all saved in pickle files because it's the most simplest way, and it's even in the book, that which is that O'Reilly book of hands-on machine learning with TensorFlow and everything. Even like the second chapter or something, they have mentioned like it's the best way to pickle files are best ways to save models or any kind of data that you're working on, because in Excel, suppose if there is some kind of special characters and stuff, what happens is that the columns sometimes the format is completely wrong, so some data gets corrupted and you can't use it like the way you wanted to, and you have to all over again start over by engineering it again. But when it comes to a pickle file, you can directly just open it like that, and you can, there is no issue, there's no format issue. So it's, I think pickle is like the easiest way to do it. So this is the final part. Wait, I came to the first one. Final part is the bid prediction. So the players that I recommended from that previous one, I get it in this. So this again, like I had to, so in the previous one I had used the KNN model, so that was pretty simple. It's a supervised one because you're giving it label data, and then you're just telling it to, like, make the closest neighbor to it, and you're just like, just selecting one player, one kind of value, and you're giving it to that, and you have to find the closest distance of the rank and everything. But in this, uh, I have so there's a lot of things, imbalanced data set and everything. So first of all, it's called stratify. I have to stratify the data. So like like some people's wage would be above, I divided them into four different parts. Like, the below, if they're earning below around 100 million, below 100 50 million, I mean 50,000, or okay, 80,000. If they're earning below 80,000 a week, then it's like one kind of player, and if it goes more than that, it's another kind of player. And like, so all of them I had to stratify first, and then I had to put them second, divided into train and test. So after that, so you can see here, like, uh see, this is the upper value, this is the cutoff thing I've done. And after like, this is like after the trade is a trainer test has the same distribution of values. Okay, so that's what I wanted to do, like the training set and the I should have the equal amount of, otherwise when you try to do the prediction, it would go completely wrong. So I just I just fit I scale the data, and then I just fit it normally on all the models. Okay, I just directly do this, and I put a for loop, and I just put all these models, and I just directly train and test it, and I calculate the test error, the CV error, the train error for each of them, and you made a graph of it, and whatever has the least in all the three, that would be the best model. So here you can see that test is the red one. uh, so here SVR is doing the least, decision trees are also pretty less, and XG boost is giving very less error. Okay, yeah, sorry. Okay, yeah, so this is just the basic version of it. I'm sorry, I have done this model like long, I did it last year, and it's been a while. So I've been thinking to make this video for a while, and I'm still like recollecting everything. So yeah, so I made this thing, and then I got this all these values. Now what I wanted to do was, I just wanted to make my model better. So before going to that, I'm not going to hyper tuning at the models right now. First, I'm just going through my uh, there are different ways to find feature selection. One is PCA, where you get a lot, like if you have a huge data set, suppose you have label data, right, like category values, and you have a huge number of categories, you can use dummy values to get like the zero ones of all of it, and then you can use PCA to like reduce all of it. So because only the important ones that keep repeating all the time, that will be like taken into consideration. The other ways are you can use one is by feature selection of k-best. It will tell you the most important features, and the second one is called feature importance in random forest. There's another there's a library like that. Yeah, so this extra tree regressor you use, and you can find the most feature importance. So here you can see, like, like I can't show you, but if you see that overall is the highest. So what I did was I tried to find between both. First I used a k-means method, k-best wala method, and then I used the feature this thing. So whatever was like matching in the first 10 of both of them and both the models, I selected those, and those were the features that I'll be working with. All right. I just took it as a double. I have there's no scientific because I just want to double confirm it, so that's why I've done it. And obviously, I have not done this completely all by myself. I have gone through a lot of Kaggle notebooks. I've gone through a lot of these things, and whatever I like from each this thing, uh, I have taken out and used it. Modified it in on my own way, and I've put it and used it. So after that, I finally get my data set, and then I split it and train it. No, I don't train it. I train it again, and now I do the hypertuning with each model with different. Each model now I hypertune it with different set of values, and I find the errors for each one of them, and I find the best model for each one. So you find for this is for grid search, and I use a decision tree regressor, and I get these values. Then random forest, I find again the hypertuning methods and I find these values. Then random forest, again I use these and I find these values. So yeah, so the next thing, so yeah, basically I do all that everything, and then I do it support vector regression, linear regression, and I find the least this thing again. Oh, I didn't run any of this. Oh god. Okay, so basically, what happens is I do it. Okay, I didn't. Oh, I never noticed this. Oh, I stop. Oh, this is like me trying. Okay, all that. Okay, so yeah, I did all that, and basically, if I kept running this notebook, what happens is if I just delete this 49th line and I kept running it, basically you can see like which model was the best. The best model was XGBoost because it gave the least error, and then I fit it into my the train data set from my the previous part, and then I find my final value and I get that. So that was the whole theory behind it. And then comes the deploying part. I chose Heroku because it's free. Even Google is free. But then there's you have to do your credit card information and all that. I am kind of lazy to do all that, so I just choose Heroku instead. So basically, this is just the notebook for explaining all the theory part. What you have to do for deploying is that you have to make a main.py file where you are showing all the same thing, that whole data engineering process I have put here. All right, and all the everything, and then you have to make. I use Flask to get the website rendered and everything. You can see the static and the template. Statics are the image. You can see. You can't see. Is that LinkedIn photo? And my favorite icon is me. It's like a meme. I posterized it and everything. And then the templates is this base HTML. So all the design you see this website, the whole thing behind it. It took a lot of work. I asked a lot of my friends to help, and so the first problem I had with deploying it was I was running the model live in Heroku, and what happened during that was because that happened, and what happened is that since it was running live on the dataset, it took so much time to load. It loaded, but it took a lot of time, and it was too slow. And sometimes it would crash also, and you wouldn't get a result. So I wanted to make it simpler. So what I did was I just the pickle file. I trained that model and I kept it always. And whenever you just type in, it automatically just gives you the answer. So this is for all the this thing. You can see me in like in this py file. You can see I open all the models and train.predictors, and then I use it for the prediction part of. So yeah, there's a lot of. It's kind of annoying when you try to if you have to go to keep on debugging here and there. कुछ तो गड़बड़ होता ही रहता है. Then requirements.txt and everything, and then that's how I finally deployed it on Heroku. So that's about it. Thank you for watching, guys. This was a project I made. So yeah, that's about it. Yeah, thanks, guys. Peace out.